Thank you, Per. So, hello everyone, I'm Sébastien, like Per said, and you might have heard of this Wikipedia word list before. This time, actually, Per misspelled my first name as Sébastien, like Einstein, so I'm hoping that you're not expecting too much. But so in 2012, at Password 12, I presented the evolution from the first Wikipedia word list that I published on my blog in 2009 and thought that maybe a friend or two would read, but never expected that it would attract such attention, and how I improved it in 2012, etc. But actually, that was not the very first one I did. I did one a long time ago, I think 2004, which was really just me playing in a corner and not thinking of releasing that for anyone. But it was already proving very useful. And after around 5 years, I thought I really needed to update it because, well, for example, Twitter had become a new big thing, and my 2004 or 5 word list didn't even have the word Twitter in it. Also, in the meantime, what I had started as a Wikipedia word list purely from the Wikipedia site, it's maintained by the Wikimedia Foundation, which now has hundreds of sites in each language. For example, you can see for the English language, there's the English Wikipedia that you know, but there's also Wikibooks, Wikinews, Wikiquote, and so on for each language. So the biggest 3 being English, then German, then French, and other big languages. So this one was still quite quick and dirty, very simple, just cut based on spaces, punctuation, that kind of stuff. And it had really a huge amount of entries in it, 58.5 million of purely alphabetic sequences, because if I added the numbers as well, then it would have been ridiculous, even more ridiculously big. It's 213 megabytes compressed. I think uncompressed, it's a text file of around 700 megabytes or something like that. So it was really something that I thought I'd just put on my blog and maybe a friend will use someday. But then people at DEF CON started using it, talking about it, etc. And I think, oh wow, I really need to do something about it, because it's really bad. When you start looking into it, it was all kinds of junk in it, because when you're on Wikipedia, you think it looks quite clean, and indeed the biggest pages, the most popular pages are so frequently visited that if someone would try to deface or vandalize one, then quickly someone else would correct that. But there's actually many pages that don't get so many visits, where you can just write all kinds of stupid things, and that stays long enough for my program to pick it up. So in 2012, I discussed how I was trying to reduce all that amount of junk, and then I also increased largely the number of sites, because the Wikimedia Foundation continued growing in the meantime. So we went from almost 400 to almost 600. Now there's much fewer entries, only 28 million, but it's much better quality, and in that sense I look forward to Dimitri's talk tomorrow about evaluating the quality of word lists. But at least looking at it, I think it was much better, and it also even came with its own compression algorithm, and it was not just a text file anymore, but even a program that you could ask to filter to get only Spanish words. And for example, if you know that I'm using an English keyboard, then it's hard for me to type French characters. So maybe my password doesn't have French characters in it. So you can say, okay, I'll just take the English key map and that kind of stuff. And also for WPA, you are not allowed all the characters. Sorry. So you can also filter by that. And then continuing on top of that, in 2014, last year, I was also at the conference, everyone was expecting a new word list, and I thought, well, yeah, I'll have not just more updated information in it, but also new features, etc. Like this is a slide from the 2012 presentation. I hope you followed the talk yesterday about the Markov chains, so I can skip that quickly. But in 2012, it was around the time of the US elections of Barack Obama versus Mitt Romney. And because you would see so many posters of Obama for president or Mitt Romney for president, you would imagine that people would see that outside of the window and choose that as a password. So you think, well, let's see how I can get to that as a sentence with the Markov chains, etc. But it's much easier said than done because Mitt is also a Scandinavian word. So from Swedish songs and Norwegian songs, etc., it actually goes quickly in other directions at the top. And also if you're hoping that at least you have the probability of going or jumping from Mitt to Romney, then the third one, Mitt Romney for president, it's not even there yet. So that's actually a lot of work. And as was said in the talk yesterday, it was taking 5 weeks, I think it was, for calculating the 6 steps. So in the case of my word list, with like 38 millions of words or something like that, so I have to compare 38 million, the probability of each one to connecting to another one of 38 million, etc. So it grows exponentially, etc. It's a big problem. But anyway, I thought, well, it was going to be awesome, but in practice, what I started noticing was that actually in practice it cracks fewer and fewer passwords. So that's really not good. So then I realized it sounds like a familiar problem of something that the more I think about, the worse it gets. I had an ex-girlfriend who would often tell me, Sébastien, you think too much. And I think she's right. So, so this is a character from a Belgian comic. I didn't, unfortunately, have a chance to go to Paris to scan my own version. It's supposed to be in French. That's why it's in Spanish. But and also that's why I only have those parts. But it's a side character that is recurring every now and then in those series of comics. And all he ever does is just his, how to say, pondering about crazy equations, etc., and completely oblivious to what's happening around him. So sometimes I have to be careful that I don't become like that because that could be me shopping, me clubbing, me jogging, etc. And then finally, when for the first time he speaks in those comics, he says, I don't speak Spanish, but it's basically, I found it, it's amazing, ha ha ha. And so I have been spending all this time optimizing my algorithms, etc. And what's the point of that if in the end it's leading to nothing? Or what's the point if you're a nuclear physicist having solved all your crazy equations, if you then get mistakenly eaten by a vegetarian dinosaur? So I thought, okay, I really need to stop overthinking, and let's start from scratch. What exactly is a word? So that's a really old graphic. I think it was maybe even the, well, early noughties, do you say, or 2002. But at the time, of course, it was funny by itself. But I also like how true, for me, it's become the sub-description there, because you have words that are, you would normally consider just letters, etc. But you will see now it's actually letters and shit. So how do you then isolate a word if you don't want to take into account the punctuation at all? So for example, you all know this XKCD comic. We quote it often in the presentations. And he gives this advice of creating a passphrase based on 4 words. And then there's lots of debate around it because he defines the entropy of that as being quite high, but other people would say, well, 4 English words of the dictionary, I can easily combine them and crack that quickly. But the question is, are you sure you really have all the words? Because the author of XKCD is a former NASA engineer. So I imagine that might be what he has normally on his desk. He has like a battery, a staple. He's into correctness as a physicist or mathematics engineer, and maybe he's into horses too. So that might be his kind of vocabulary, but what if you're a terrorist, for example, and I've seen in the past some had even their email address was Jihad 11 Septembre, which is French for 9/11, and you think, wow, if they already have that obsession in even the name of their email address, what do they put in their password? So maybe they will put 9/11, then the type of aircraft or one of the 2 planes that crashed in the World Trade Center. Then normally, I imagine the ammunition of choice for terrorists would be 7.62 for the Kalashnikov, but you'll see I find this other .40 Smith & Wesson an even better example, because it's really difficult to make a computer understand that this is a word by itself, because you see it has a dot at the beginning and ampersand in the middle of the second word and space in the middle. And the last part is, well, why not make it Christian terrorist with a quote, the most famous passage from the Bible. So, as I was saying, this .40 Smith & Wesson cartridge, that's just parts from the Wikipedia article about this ammunition. And as you can see, in the beginning, the word itself is not at the beginning of the sentence, not in the middle either, but somewhere in the middle. But then in the second entry, it's starting with a dot. And at the end, it's at the very end of the sentence, but you still have to make your program understand that the dot at the end of the sentence is not part of the word as the dot before the 40 is. So, by lack of a better word, I thought, well, why not call these more complicated words? I don't want to call them complex words, because then we might confuse them with complex passwords, and they are not. But they're more complicated than regular words, so that's what I refer to as beyond words. Then there was a presentation in other Passwords conferences before about a new tool called WordHound. And it's a great tool that you can use to build your own word list, etc. But it's doing what I was doing at the beginning, cutting based on the spaces and punctuation and that kind of stuff. So how do you not take this approach and try to zone in on this word in the middle of the sentence without knowing anything about what's the beginning and ending of a word? So in the upper left, for example, we have a pass, let's say, that is looking at each sequence of 6 bytes. And it's in red because it has no chance of zoning in onto that word, because it's 7 characters. So it's in red. Then the upper right, it's in yellow when it's just before or just after on it, green when it's really on it. And the rest also is 8, 9 bytes, etc. So no chance of zoning in onto that particular word. Of course, it will find other words that are 8 or 9 characters. So one idea that I thought might be clever was, hey, if we look at what is actually surrounding each of these sequences, so I did a little test. Well, that's from the page itself, etc. And you can see on the left, if you look at the sequence that is just before the .40 Smith & Wesson ammunition, you will see that it's not stable at all. On the left, it's being preceded by all kinds of different characters, and then the following characters is always a W. While on the right side, you have the opposite, that it's only ever preceded by a dot, and it's followed by all kinds of different characters. However, in the middle, it's fairly stable, that it's either a space or quotes or a dot on the side, but overall it's balanced for this 7-character sequence when you are right in on it. So I thought, hey, this is working quite good. So I will now spend a lot of time into kernel hacking to allocate gigabytes of memory contiguously and process all of Wikipedia, etc., to find all the unique sequences of 7 characters, 8, 9, and so on, and look into renting Amazon servers, etc., to do that. So I thought that's going to be awesome. But when I started getting the first results, actually, you find that when you look at the 9-character sequence, so you find as a stable sequence the same word of .40 Smith & Wesson with a space at the beginning and at the end. So those, I forgot to mention, but the white rectangles are to show the spaces. So they are prefixed or preceded by all kinds of characters on the left, all kinds of characters on the right, etc. So this method of trying to isolate this particular sequence by itself is not working so far. And then I thought, sorry, I'll get back to that. So I thought I need a better way, because as humans, we can obviously see that there's a word in there or a concept, a beyond word, that is repeated many times throughout the page. So just by a glance at the page, we can decide that it's actually a thing, this .40 SNW. It's a beyond word by itself. So I thought, hey, well, maybe it's a vision thing. So if you're familiar with computer vision, and since those kind of graphs are already starting to look like neural networks, I thought, hey, it's maybe a neural network problem. And then, I don't know if you followed earlier in the summer, Google released this. The latest advances, this going deeper into neural networks, where they are trying to teach their machines, basically, how to recognize dogs from not necessarily having the perfect training set to say, well, this is all kinds of dogs that are possible. So they are basically taking all of Google images and letting the machine trying to figure it out by itself, which is sort of like what I'm trying to do with giving it Wikipedia and not telling it what exactly a word is. But as you can see, that's the state of the art of Google research itself, which has lots of clever people and lots of time. And it still finds dogs absolutely everywhere in the picture, in the nose of the horse and in the helmet of the knight, etc. So that's when I realized, okay, maybe I'm overthinking again. So let's drop all of that and just see what happens if I just keep it simple, stupid, to reuse the Unix philosophy, for example, and just pipe out all the output of my very early program to cut all kinds of fixed sequences from Wikipedia. And I started cracking all of these from LinkedIn, for example. And that's the first thing I noticed is if you see, it's hard to say what the person meant to have as a password. Of course, when it's exactly 16 characters, or maybe it's, how do you say, on the boundary of a word. So you don't know if it was supposed to be longer, but there's many of them where it's, for example, academic excellence, the second column at the top, it should have been excellence. So, you know, there's something happening here. And I don't know if this is something that is being done already in all the cracking tools, but you have so many websites that you at least used to force you to have a password smaller than their fixed column size in their database when they were, or maybe still are, storing your password in clear text. Or if they didn't tell you, they would just silently truncate your password to 16 bytes, in this case, for example, of LinkedIn. And every time maybe you will be typing academic excellence or Alice in Wonderland and so on. But concretely what's happening is that it's truncated, and that's only that part that is hashed. So for example, last year, Jens from Atom from Hashcat was talking about his method of print mode to create, associate words together to do like a correct horse battery staple. And you have to keep in mind that you might have to cut the last part to fit that kind of model. And also note that I wrote bytes as opposed to characters, even if I sometimes make the, I should really distinguish the two. It's because it's 16 characters if you're only using English characters, but in Unicode, of course, to support all the languages of well, French accents and everything, Chinese and new emoji, etc. Each character can take between 1 and 6 bytes. So when it's truncated at 16 bytes and you're choosing a password in a language that is using complex, longer characters, maybe your password is actually only 3 or 4 characters in the database. So another thing I noticed is I came across this, and I thought, oh wow, how did that get here? It looks like one of my old passwords. So I was panicked for a moment, and then couldn't, it wasn't my old LinkedIn password. So I Googled for it, and I found it in the middle of a hexadecimal dump. So I still have trouble understanding how someone chose that as a password. Maybe they just copy-pasted randomly from something. But at least it's showing a use of cracking passwords by just keeping it simple that you would have otherwise had really trouble cracking. So if you remember the title of my first slide, this in the beginning was a word. I was very proud of that because it's one of the first things I cracked as well. 29 letters password. That is actually a real password, and I thought, well, perfect subtitle for my presentation. Except then, looking back at old stuff, etc., I came across this, showing that, of course, it was also cracked within 24 hours in 2012 when the LinkedIn reach came out. So I was disappointed, but still, as you can see in the bottom right, I cracked up to 42 characters. But they make a great point of using the Bible to see beyond Wikipedia what you can put in it. So I said, well, let's see what happens if I put all of Wikipedia, all of the Bible in my new, very simple cracking thing. And then you find all of these complex beyond words, but still bad passwords because they are quite easy to crack. And as you noticed in the upper left, it also says Han Solo, and I thought, what's Han Solo doing in the Bible? And okay, what I find even more awesome is that it's in the Gospel of Luke. So then if you think, well, for some people there's other types of Bible, and sorry, I have to skip, but I did that, of course, for the Quran, the Torah, etc., and it's just as useful. But also you can do it for...
You can find Star Wars in all of them.
Not yet, but no, I meant that some people take Star Wars so seriously that they are likely to have some Star Wars reference as a password. And if you know these wikia.com sites, it's not part of the Wikimedia Foundation sites that I was processing so far, but it's still the same software, the same kind of database, etc. So I thought, hey, let's take all of Star Wars and see what we can find, and you can see there's lots of Star Wars passwords. Then, actually, somewhere in there, at the top second column it says "I'll be back," which I guess is somewhere in Star Wars, but for me it means more like Terminator. So I thought, hey, let's take not all the movies from Wikia, but let's take all the subtitles that I can find on the internet, and they're very small files. So now you start cracking lots longer passwords that are streams of consciousness. As you can see, for example, at the top it says, je suis en vacances, I am on holiday, and well, sorry, I have to go faster. And other source of stream of consciousness is Twitter. So from Twitter, you can get a full feed of everything that's public, etc., but you have to pay for it. That's called the Firehose. But you can also get several gigabytes per day just as a developer. You register for free, and you can use the second link. So again, in this idea of people choosing passwords the way they think in their heads, you can see these are real tweets that I copy-pasted that helped me crack what I highlighted in green. So some people on LinkedIn, their password was, I always forget my password, or I should remember, I need a vacation, etc. So all these are real passwords that you crack very quickly with Twitter. If I did Twitter, why not IRC? So that's also cracking other things. And then I started seeing a pattern that those ones and many others, I had to manually pick several, they are common to all of these, from Wikipedia, Twitter, IRC, the subtitles, etc. They appear everywhere. However, they crack a lot faster on the smaller ones like Twitter and IRC, where it's a more human talk than what you find in Wikipedia, where it's very, maybe not formal, but talking in general, as opposed to what you are thinking in your head. It's rarely the first person on Wikipedia.
How many more slides do you have?
That's the end, basically.
Yeah, I will let him finish. I like this stuff.
So yeah, basically this presentation, I'm sorry if you expected some brand new awesome crack or something like that, but as opposed to that, it's some ideas that I have been brainstorming alone in my head, and I need help, basically. So you are more than welcome to suggest ideas, etc. And so, for example, one thing that I think we could do soon that would already improve that is find some possible optimization in the way we hash all those passwords to allow for this cracking using a huge pipeline like the Twitter Firehose. So, for example, the first one is if you are familiar with CRCs, you can actually compute the next one by subtracting the previous one, but that's probably not possible with more complex hashes like MD5 and bcrypt and that kind of stuff. But at least we could do some optimizations of calculating perhaps all the hashes of 8, 9, and up to 40 and so on characters in one go by using the update function and that kind of stuff. And there's also lots of other interesting properties of languages, like this zip slow. You have to read more about that. But overall, if because this is a security conference, at least the one thing you can take from this is that, yes, do not use a passphrase that might have been written anywhere ever, because look at all of these, those are all insecure passwords. So,
even that passphrase there had not been written, so you can't do that.
Those are all real LinkedIn passwords that I have cracked. So, and you can see they're sort of complex. So you think, well, they would have been strong, but actually they were quite quickly cracked. So to comply with the Paris demands, I have included a kitten, and I welcome any question.